Hi everyone, so today I will be showing you guys how to find the curve sketch using derivatives, and the first thing you have to do is find the derivative of f of x. So you start with the derivative of f of x equals 3x squared plus 6x minus 9. And then next thing you have to do in order to find the critical points is to factor the derivative of f of x. So you can clearly take out a 3. As you can see, a factor is very cleanly out of this equation. And then you can factor it again. So this equals x minus 1 times x minus plus 3, And then, in order to find the critical point is when the derivative of f of x equals 0. So basically what you do is you need to make sure that the derivative equals 0. So you plug in 0 for this, and then you solve for x. And then so 0 equals x minus 1. So plus 1, x will equal 1. And then you do 0 equals x plus 3 minus 3 minus 3. X equals negative 3. After you find this, you then now need to find when it's increasing and also decreasing, and also you need to find when it's the local max and local minimum. So you can find when it's increasing and decreasing by using these 2 points and plugging it in kind of a number line. So you can make a number line. And then since this is negative 3, you can place it right here. And then you can place 0 here, which isn't very important right now for us. And then you can place 1 here. But 0 is just like a reference point. And then basically what you do is you plug in something on each side. And if you want to plug in something less than negative 3, you can just plug in negative 5. For instance, it can be any number less than this. And then something more than that, you can plug in 0 for here. As you can see, 0 is right here. And then you can plug in 2 for here. And if you plug these numbers in to the derivative of f of x, and it's easy to do this if you have a factored form for the derivative of f of x, you just plug negative 5 in. You see that this will produce a negative number. This will also produce a negative number. And these multiplied together is a positive number. Negative times negative equals positive. And then if you plug in 0, you will find that this is a positive for here and a negative for over there. So therefore this will equal negative. Negative times positive is negative. And then you can go on to over here. If you plug in 2, you'll find that both of these are positive. So you end up with a positive. And with this information, you know that the derivative is increasing, is positive when it's here, and it's negative when it's here, which means it's increasing in the intervals of negative infinity to negative 3, shown right here, and also from 1 to infinity. And we know that it is decreasing from negative 3 to 1, shown right here, because this is a negative. So these are the points when it's increasing and decreasing. And now also using this number line, we can find when it is the local maximum and when is the local minimum. And we can do this by looking at the graph. At the number line. And then, so it tells you that it is increasing here, since it is positive. And then it tells you it is decreasing. So this is clearly a local maximum, as negative 3 would be this point in the graph, and it would look like this. And then over here, it would look like this, since this is negative and decreasing, and this is positive, and increasing, so it would look like this. So this is a local minimum. So our local minimum would be at f of 1 equals -5. And you have to plug in 1 back into f of x to find -5. And this is the way you always have to use it. And the local maximum is f of -3 equals 27. Now we can move on to the second derivative, which will tell us some concavity, and also it will tell us the point of inflection. And to find these things, you first need to find the second derivative, so you find the derivative of this derivative. So the second derivative of x equals 6x plus 6. And you have to ignore the 9 because the x will turn to 0. 0 times 9 is 0, so it's not there anymore. And then, so this, you can just factor 6 out. So, and then to find the possible point of inflection, you need to find what x is. And also, that is what you need to do in order to find the concavities. So, you have to plug in 0 for this side. X plus 1 minus 1 minus 1. X equals -1. And then what you do to find the concavity is you make another number line like the one that we did previously, and you do basically the same thing. You have to plug in a number less than -1 and something more than -1 to make sure there's both sides. So if you plug in -2 and if you plug in 0, you'll get -2 into this. This will be a negative point. If you plug in 0 into this, it will be a positive point. Now we can use this number line that we just found to find the concavity. So we know that it is concave down from -infinity to -1. And we know it's concave up from -1 to infinity. And we know this because it is facing up like this, concave up and positive, when it's from -1 to infinity. And we know it's concave down, negative, from -infinity to -1. We can also find the point of inflection with the number line that we just constructed. And we know that -1 is a point of inflection because it is negative over here and positive over here, which means it changes from negative to positive at this point of -1. So we also need to find what f of -1 is in order for us to graph it better when we are actually constructing the graph. So if you plug -1 back into f of x, you will find that it equals 11. With all the information that we've just found, we can now start on the graph, and we can also find the x-intercepts to make the graph more precise by just making f of x equal to 0 and solving for x. And so now we can get started with what we have, and we know that this is the local maximum. F of -3 equals 27, and then this is a local minimum. F of 1 equals -5, and we know it's increasing from this interval. So we can just go ahead and draw this. And then we know it's decreasing from here. And it has to go through the intercept. It goes back around, goes through the minimum, and then increases once again. And we also know that f of -1 equals 11 is the point of inflection, so right here. And so we are correct, and we've graphed this right. And we also know that this is concave down with the stuff that we just solved for earlier, and this is concave up. So this is the correct graph for this equation.